Okay. Okay. Can someone confirm is my screen visible?
Yes, sir. It's
Sure. So in last session, the indexing has been covered. I hope so. So dense index, sparse index, multi-level index. So yeah, we'll start with B tree. So before going to B tree, I hope the basics of B tree and B plus tree has been also covered. What's the purpose of B tree and B plus tree, right?
yes, sir.
Okay, basically, we use B tree and B plus tree for the indexing mechanism. So, what are the concepts we have seen? In order to maintain these indexes, so we are using this B tree and B plus tree. Okay. So, before going to B tree and B plus tree, uh, I just state some of the basic things which is here. So, there are various types of, not various types, based on the order. So every B tree and B plus tree has an order. So based on the order, we can say two order tree, three order tree, and four order tree. If it is two order, it will have one node and two child. That means it will have kind of one node and two child. These are child. These are one child and two child, right? Similarly, if it is a three order tree, uh, we will be denoting like this with two nodes with a split. This is my first node and this will be my second node. And everything will have a child. Here, this is my first child, and this will also have my second child, and this is my third child. Similarly, if it's a four order tree, and it will have three nodes with a split like this. This is my first, second node, and third, and it will have four pointers. I can say this as a child pointers. Okay, and every node will also have node pointers also. I'll come to that. There is a differentiation between B tree and B plus tree. In B tree, it will have a node pointer where it actually points to the record in your table. And this will have like this four child pointers. Okay. And these are the some of the basic formulas which you guys need to remember. And the non-root node, which is basically means the internal nodes, right? In weeks 8, we have seen about the binary search tree, the internal nodes. So the minimum number of child pointers over the internal nodes, it will be C of p by 2, and the minimum number of key is p minus 2. So these are some of the things which you guys need to remember. So now let's start with how to insert the values in our B tree in order to construct uh, our B tree to index the particular record, not particular record, to index the record in our table. Okay. Suppose these are the values that I need to insert in my B tree. So finally, we will construct a B tree. So here, what is the order they have mentioned?
Three order.
It's a three order, right? Three order means how many nodes will it have? Two nodes,
Three child.
three child. So whenever you find any order, similarly I can write it for, it can be n order also. Okay. So in course we are not going more than four order, but it could be any order. So if it is n order, n minus one nodes, and n child pointers. Okay. And let's start constructing the tree by inserting. Okay. First, what will I do? First, I will insert 20. This is how. Okay. Next, 20 I inserted. Next, 50 I want to insert. 50 I wanted to insert. Okay. Now, since this is a three order tree, I cannot extend 40 here, right? Because at max, how many nodes I can have? Two nodes and three child pointers. So I need to split this. So how can I split this? And anyone?
Sir, 40 will go above and it will split left and right from 20 and 50.
40 will go above, right?
Yes.
So first 40 will take in between, not at the last, right? So I'll write it here. So this something I would like to insert something like this. Since this is not possible, what we'll do, we'll split this tree and write it like this. So we always have to split in the middle node. So after inserting, you can split this middle node. So 40 will go up, 20 will be left side, and 50 will be right side. So my final node will be now, as for now, after inserting 40. So this will be something like this. So now I need to insert 80. Where can I insert 80 now?
Right side of the 50.
Right side of 50. So here, since it's a three order, I can have two nodes at max. I no issues because I know need to split here. Okay. Next, I need to insert 90. Where can I insert 90 now?
It will split again from 80.
So I need to insert 90 here. So, but since this is not possible, I need to split. So what I will do, 80 and 90. So after inserting, what I will do, since I found this is not possible for the three order tree, I need to take the middle element and I need to split it and push it to the one up level. So, so how it will look like is now 40 will be there, 80 will go up, and 20 will be on the left side. Here 50 will come and 90 will come here. Okay. So I'll rewrite this also. So 80 will go here, 50, 90. Okay. Next, I need to insert 10. 10 where can I insert?
It will go left side of the 20.
Left side of 20. So I don't have any issues here. So since it's only two nodes. Next, I need to insert 30. 30 I can insert here, but now I need to split it since this is not possible. So I need to split this 20 and I have to shift one level up. So if I split and shift one level up, it will look why don't I will just draw it here only. So if I shift 20, so it will have like this, will have like this. But this is also not possible, right?
Yes.
Since it is having three nodes. It should have maximum of two nodes for the three ordered. So what will we do? We'll split one more time to get the two node and three side for the three ordered. So after splitting this, it will be 40. We'll go to the top again, the middle element. Left side 20, right side 80. Now again, where can I draw?
10 and
10 will
30.
be on the left side, 30 will be on the right side of
Right side.
20, then 50 will be on the
Left, mm, left side of 80.
left side of 80, then 90 will be on the right side of 80. So I'll erase this in order to avoid any confusions. So once I inserted 30, now I should insert 70. Erase this also. So now I need to insert 70. 70, where can I insert?
Left side of
Right
80.
of right of 50.
This, this is clear, right? Where should I insert? First, we need
Ah,
to traverse. So we'll check 40. If 70 is greater than 40, so we'll go right side. Now
Left side
80.
of 80.
70 is lesser than 80, so left side. Again 50 is there, then we should insert. Okay. So I hope it has been covered in week 8. That's why I'm not
uh-huh.
focusing on this. Okay. Now, since it is having only two nodes, we don't have any problem. So this is fine. Next, we need to insert 60.
Left
So
of I
I,
think
so
70.
if I insert 60 here, this is how I'll be inserting, right? So since it has three nodes, since this is not possible, I need to split this and move one level upwards. So finally, my tree will be looking like this. 20. So since I need to, just let me complete the left tree, 30 and 8. Now, not just 80. Since we are splitting the 60 and moving upwards, so this will be 60 plus 80. So it will be 50, 70 will be here, and 90 will be here. So this is how my final B tree will look like. Okay. Any doubts in B tree? How to insert the elements in the B tree?
So it is at the right side of the 60, where it
Yes.
is. So it is the branch 60. It is a branch of 60, or it is two blocks. Not this one.
Yes. I'm not getting what you are trying to say.
No, this okay. No, 60 should come right.
This is left of 80, right? And
Ah,
See, we are inserting 60 here.
yes,
So
this way.
we are just splitting it and moving it to top.
Okay, okay, okay,
sir,
okay,
can you
You
repeat?
okay.
carefully see,
Like,
if you carefully see, everywhere the order maintains.
sir, can you repeat this order? I don't get it. Three order, two nodes, three child, and n order, n minus one node, n child. Only one example for three nodes order. I got
This
it.
is three ordered tree.
Okay.
Oh yes,
Three
yes.
ordered three ordered tree means maximum we can have two nodes at any point and three child pointers. You can see here I have two nodes here and three child pointers maximum. So whenever we found three nodes, whenever we insert and we found three nodes, what we did, we just split the middle element and shifted up one level upwards.
Okay, sir. Okay, got it.
So is this clear to everyone?
Huh. Yes, sir.
Okay. So the final B tree will look like this. Something what I missed here is the pointers. I haven't drawn pointers explicitly, but pointers will be there as if you guys have seen the live session. So these are the record pointers.
Like
These are
visited ones.
no, you can see record pointers in every node, right? Record
Huh.
pointers. And these are the child pointers. Child pointers nothing but it basically points to the child of that element. But record pointers what it does is to if you have a table with ID with all this 20, 20, 30, 40, 50, 60, 70 up to this record pointer will directly go and point this 40 because this is the values that we have indexed, right? Similarly, every record pointer will go and point to the actual record in the table in order to index. So index basically it helps to access faster in a table, right? To access any particular record, it will help you to access it in a faster way instead of searching the whole table. So all these pointers will directly go and point to uh, the record of particular record in your table. So let's move to B plus tree. We'll see B plus tree as well, how to insert the nodes in B plus tree. Okay. So the one advantage of B plus tree is it has a linked list. I hope everyone knows what is mean by linked list. So linked list so that we can have a sequential access also. And as usual, the binary one. So here let's take an example of 4 order B plus tree. So in 4 order, how many nodes I can have? Hello.
Three
Three
nodes.
nodes.
3 nodes and 4 child pointers, right? Is it clear? So let's take a look at it so that it'll be clear on how to insert B plus tree also. One minor changes, it's having a linked list and all the elements whatever you are seeing it that will be found in the bottom level of the tree. Okay. So first we are inserting 1 and next we are inserting 4, next we are inserting 7. So this is in which order right now?
Increasing order.
4 order, right? Since it has 3 nodes, this is in 4 order and so if I try to insert 10, it will become 5 order. So which violates my given question, 4 order should be there. So what should I do now is I need to split the tree. Since we are splitting the tree after inserting, so always we need to take a middle element while splitting the tree. Now, if you see, we have two middle elements, 4 or 7. So, in this code, we always take the right side of it. So, we always used to take the right side of the element. So, which is 7, and will split like this. 1 will be here, 4 will be here. And the good thing in the B tree is whatever we are splitting, that will also be in the bottom level of the node. So again 7 will be there and 10 will be there. As I said, this is as usual the child pointers. The record pointers will be there in the bottom level of the tree, every record. Plus it will have a linked list between all the childs. It will have a linked list between 1 and 4 and 4 to 7 and 7 to 10. So that it ensures that you have a sequential access also. Okay. Any doubts so far?
No, sir.
Anyone? So this is very important. And while splitting the 7, you do remember this, whenever we are splitting, we are having the same element in the child node. And if you see the 7, and if you find the same element, that should be always right side of the split. 7, I'm having it in the right side, not on the left side. Okay. And if it's having a even number of order, you need to always take the right side of this element in the middle.
Sir, what is use of linked list?
Linked list, you can sequentially access. So if I wanted to access 10, so how will I traverse? So I need to
Like,
traverse from
s-
7, then I will reach 7 and then 10, right? So this is one way of accessing. Suppose if my current point is in 4, instead of again coming through binary tree way, I can directly go to 7 and I can directly go to 10.
sir, can you repeat once?
Uh, I'll Maybe at the end, after completing the tree, I can give you a better example. Means
Oh,
better suggestion.
What is the difference? B and B plus.
Uh, the first difference is linked list. Okay. So in bottom level, we have a linked list with all the nodes. The second level is the second difference is you are having the same node at bottom level also, which we haven't seen in B tree, right? In B tree, generally we used to split and we don't use to store a copy of the element in bottom level, but in B plus tree, we used to store the same element in the last level of that, which is my bottom level of.
So the process is same.
Yeah, the process is same, but these are the two major differences that you need to remember while inserting a node in B plus tree.
Okay.
So I'll erase this and I'll draw a neater diagram. So 7 will be like this. 1, 4, and here 7, 10. Okay. So in between, I'm not drawing any linked list, but it should also be a linked list. Finally, I will show a neater diagram than this. Just draw a linked list here alone. Okay. So next, I need to insert 17. 17, where can I insert?
Right side of 10.
Inside of 10. So do I need to split anything here?
No, no.
No, sir.
No, right? since my B plus tree is 4 order, it should have 3 nodes, maximum of 3 nodes. So no issues. Next, 21.
Yeah,
21, where can I insert?
right of 17, not to split.
Right side here. So this will lead to a split.
Yes.
So which element I should split and move upwards? No,
17.
17, right? Since the 4 elements are there, always if you find 2 middle elements, you always should take the right side of it. So 17 will move upside. So after moving it, the tree will look like 17, and this will come as a new pointer now, 17.2. And this will point to again one more linked list. Is this clear?
So whenever they are moving up, so you're taking the copy of it, the child.
As I said, always you have to take a copy of all the elements in the uh, last level of the node in B plus tree, but that's not in the B tree.
Yeah, okay.
And next we insert 31. So 31 will be inserting here. So we don't need any split since it is in 4 order. So next what we will do, we need to insert 25. So 25 where will I insert? 25 will be inserting
Instead of 40.
like this. 25 and 31 will be here. So now I need to do a split.
Yes.
So 25 will go one level upwards, right? Since I need to take a middle rightmost element. So after doing the split, so it will look like, so 25 will go here. 25 will go here and it will lead to one more child pointer, 25 and 31. And this will be again linked with the linked list. Now, what I need to insert? 19, right?
Yes, sir.
So 19, where can I insert now?
19 is after B 17.
Okay, after 17.
I should insert in this level or this bottom level?
I think bottom level.
Yes.
Bottom level. So 90 will go here in between here.
Hmm.
So let's rewrite this. 17, 19, 21. So I don't need to do any split here, right? Since it is in already 4 order.
So 3 notes, है ना sir?
Yeah, 4 order means maximum you're gonna have 3 nodes. Is it so far? Is it clear?
Yeah.
Then in next, what we need to do is we need to insert the last element, which is 20. 20 again, it will come here. So this will look like 19, 20, 21. So I need to split the node here.
Uh-huh.
So my 20 will be the split element, which I should move upwards, right?
Yeah.
So after splitting it, my B plus tree will look like 17, 19, 20, 25. So 1 and 4 here, and 7 and 10 here, 17, 19 here, and 20, 21 here, and finally 25, 31 will be here.
31.
But this is also not possible since it's violating my 4 order.
Maximum
Right?
3 nodes earlier, no?
Yeah. So again, I should take a split. So this 20 will move one more level up, right? Is it clear or is it confusing?
Yes, sir. Clear, sir.
Oh.
So where the 20 will go, sir?
20 will be split and it will go one more level up.
What were the
So
levels,
my,
sir?
sorry,
What were the levels? Which level it will go, sir?
it will go
Root
to the
level.
level 0. Level 0.
So level 0, but level 0 had 3 elements, no, sir?
No, right now this is your level 0.
Okay, okay.
But since I need to take a split, so my 20 will go up. So this will become level 0 and my 7, 17, this will become level 1.
Okay, okay, okay. Hmm.
Okay. So my split will be, so what will I do? I'll erase this and I'll reroute this. Okay. So my 20 will be in top, and 7 and 17 will be my
Left side.
left child. Then 25 will be on my right side. Why I haven't taken 20 here? Because we always used to take the copy of the node in the bottom level, right? But here I haven't taken this 20 in here on the right side. Should I take it here or not?
Left side.
Hello. So in any intermediate level, I shouldn't need to take a copy of that element. All the element which should be in the my last level only. Okay. So I don't need to take a 20 here. This is the one of the thing that you guys need to note down in your B plus tree.
Okay, only the last.
Only the last level,
Yes.
not in between level. So whatever the elements you are having in uh, level 0 to in a generic way, if I want level n minus 1. So all should present in level n. That is your last level. So in intermediate this level 0 to level n minus 1, you don't need to take any copy of it. Is this clear? Okay. So my left pointer to 7s, it will be my 1 and 4. And this will be my 7 and 10. And 7 next to 17, what will I have? 17 and 19. And 20 will have here. And 21, it was supposed to be here. And the elements greater than 25 will come here. 25, 31. So this is how my final B plus tree will look like. And all the nodes will be at the last level will be connected through the linked list. So the one more change is in B tree we have seen record pointers in all the nodes, right? The record pointers which we have as a circular icon. But in B plus tree, you will have record pointers only in the last level. You won't be having record pointers in this level 0 to level n minus. So only the last level will go and point to the actual record in your table. Okay. So this is how your final B plus T will look like. So as it is, again I haven't drawn this child pointers in a clear way, but you can see everything has been connected through the linked list, and only the bottom, the last level will have the record pointers. These are record pointers.
Sir, can you order, like, can you explain order and children and node? Like, this is a four order and how to count.
You cannot count after building a tree whether it is in 4 order
Oh,
or
okay,
3 order.
okay. And making B counter.
That will be given in the question itself. Your B plus tree or B tree should be in which order. So while building the tree, you should take care of it, whether we are building a 4 order tree or 3 order tree, 5 order. So once you build, see from here, I cannot say whether it is in 4 order or 3 order, right? So by looking at it, it feels like 3 order to me. Uh, but we builded this B plus tree using 4 order, right? Okay. Any doubts in B plus tree?
No, sir.
So is everyone clear about B tree and B plus tree? So this is very important topic in week 9.
Sir, this PDF you could upload in one of the link you said previous weeks. You will upload all the whatever the lecture you take the PDF. But it was not updated. Only 1 to 4th week only updated. Still,
Yeah, after that I guess only week 5 I have taken.
okay, okay,
So I'm updating the some of the typos also. So I'll update it.
okay, sir.
And the major differences I listed here. So the point is, one thing is, as I said, they all internal and leaf nodes will have data pointers which we have seen in B3, and in B plus T only leaf nodes have data pointers. And as I said, no duplicate keys are there in B3, but here duplicate keys are there. All nodes are present at the leaf, which is my last level. Okay. And leaf nodes are not stored as a structural linked list. In B tree, there is no linked list, but here there is a linked list only in the leaf nodes, which is my last level again. And as a tree, B tree may or may not be balanced, and B plus tree is always balanced. So, uh, is this clear? The last one, balanced and may not be balanced. This part, I think remaining three all are clear.
No, sir.
Sir, please explain this. What is balanced?
So while inserting the B tree, there is a possibility where tree will end up something like this also. It might end up like this also, which is not a balanced B tree, right? Balanced B tree will be looking like this. It should have the same number of nodes at the last level. Not how can I give an explanation? It should have all the childs basically. If it's having two child pointer, it should have two childs. So this is balanced tree, but if I remove any one of this is not a balanced tree, right? So B3 might end up something like this, which is not balanced. But if you take a look at B plus tree, which will be always balanced, because all the leaf nodes are linked to the linked list, and it will be in same level. You won't be missing any element at the leaf node. But in B tree, might be a possibility will insert. That's the point it's trying to say.
Sir, there is also a term mostly balanced, like
There is also a term.
term like mostly balanced.
mm,
I,
Mostly balanced means that's why it said may or may not be balanced. Are you referring to the slide lecture slides? In lecture,
yes,
it
sir.
might give
Yes.
an mostly balanced also. It's almost same. May or may not be balanced. In most cases, it's balanced, but it may not be balanced also. That's
I'm not able
So could you
to
show
recall.
me
I
the
think nearly balanced or mostly balanced. I think so.
it doesn't guarantee it's always balanced, right? So, both
answer?
are same. Both wordings are same. B3 may or may not be balanced. Mostly balanced. Yeah.
Could you show me the previous the B plus what we done?
This one.
So here the second it is having. Okay, so you are saying the child has to be filled.
The child will be always equal, right? If you have seen carefully, whenever I drawn or whenever I added any number in the node, you can see the B plus T always maintained a balanced structure at the leaf level or last level. That was always there in the um, B plus T. You might have noticed, or if you haven't noticed, just rewatch once again, then you will be clear why I am saying B plus T is always balanced. But in B tree, if these elements are not there while inserting, uh, I need to insert and I can show you. Okay. 80, 90. Okay. At some point, how it will look like, I'll draw. So this is a 3 order tree, right? So 20 will be this side, 50 will be this side, 40 is there, 80 will be this side. So once I add 90, it will go up 40, 80, 50, 90. Okay, 10. Okay, here we are not seeing unbalanced tree, but there might be a possibility, as I said. Here it's coming as more balanced.
Yeah, this example it's balanced, right?
Yeah. Okay. Any other doubts in B tree and B plus tree? We'll move to the bitmap indices, then we'll cover ASHU.
Excuse me, sir. Just one clarity on the part of balancing. So B plus tree is balanced because of the linked list property it has like connected.
Yeah, that's one of the reason. It has a linked list because it maintains all the values in the leaf node. It's by default it's taking a copy of it and it maintains to the linked list. That's why it's always balanced.
Okay, sir. Fine. Uh,
Okay, let's move to the bitmap indices. This is one type of indices that we used to do. In bitmap, nothing means bitmap means 0 and 1s. Okay. So indices are done only using zeros and ones. So let's consider this is the table. Okay. So the bitmap indices for the gender, this will be like this. For example, if I want to index this gender, for male, it will be, let's consider if you want to index for male. So male, you can take 1 and female 0, 0, 1, 0. So this is what we have written here. And for female, you should take female as 1 and male as 0. That's it. Whatever the value you are trying to index, take that as 1, remaining as 0. So it will be 0, 1, 1, 0. And for income level, I haven't indexed income level here, but what will be the index for bitmap index for L1 and L2, L3, L4? Can anyone? If you guys were able to understand this, then it's good.
Like for 11, 10010.
What?
So for L1, gender is M. So we right now 10010. I think
10100, right?
no. This given na in this table bitmap for gender.
No, I'm asking for income level. This income level, this there is another column, right? If I
Ha
want to
ha.
index using the bitmap, what will be the value?
So I so can you explain? I
So again, if you want to index this L1 based on L1, it will be wherever L1 is present, it is 1, and remaining will just take 0, 0. So my value will be 1, 0, 0, 0.
okay, got it.
For L2, the value will be, you just
One
take 1 for L2, remaining 0, 0.
zero. So zero one
It
zero zero zero.
will be 0, 1, 0, 0. For L3,
401.
because at last only 1 remaining, all 0, 0. Oh. For L4,
Uh,
here it will be 1,
last before.
remaining all 0.
Ha.
Okay, this is how we can use bitmap indices.
So we create for an income level column, we create another bitmaps.
Ah.
Okay.
So bitmap, the advantage of using bitmap indices is it can just perform Boolean operations and or easily using zeros and ones. Instead of traversing and finding the element, but using the bitmap indices, you can easily able to find out using ones and zeros because the computers are faster in ones and zeros, right? Mm, by default, all the data are stored in ones and zeros. And if you are indexing also in ones and zeros, it's easy to access instead of doing any algorithm or searching uh, algorithms.
Yes, sir, got it.
Then we'll see finally how to create an index in SQL. This is the syntax to create an index in SQL. Suppose let's say this is the relation student which has the attribute, student ID, name, address, age, gender, semester. And if you want to create an index on name and address, so first the syntax is create index, and this is nothing but your index name which you wanted to give, and on, and this is the table and the attributes which you want to index. This is what type of attribute if I'm putting two attributes together.
Mm, mm,
Multivalued.
Can anyone recall from week 2 or 3?
Multivalued.
Sorry,
This
not multi-valued, right?
this is normal form.
Multi-val. See, address can be multi-valued, but generally, if I'm putting any two attributes together, like say name and age, this will be what kind of
Like
attribute?
like primary attribute or like this.
The function
It's
dependent
a
too.
composite attribute,
Okay, okay. Oh, oh.
right? If I'm putting together, we call as a composite key. Then if you want to delete that index, you can use the drop. Similarly, like drop table command, drop index and the index. And if you want to create a bitmap indices, you just need to add a keyword bitmap index and the index name, and as usual, the table name and the attribute. Okay.
The bitmap index, if you're putting automatically, it takes, or we have to make.
If you're having a bitmap indices on gender, this as we have seen male and female values, it will be automatically created using like this.
So this is enough
You
for creating.
yeah, this is enough. You just need to add a syntax. By default, internally the database manages all these B tree and B plus tree algorithms.
Okay.
Even B plus tree, B tree, you don't need to manually insert or delete anything. But that's how the indexing works in the database. You just need to create this index keyword, but the database itself internally manages all this addition of elements and deletion of elements, updation of elements in this B tree and B plus trees. That's how the database has been internally designed, and we are using index for that. And this indexing uses that algorithm of B plus T and B plus T in order to efficiently retrieve the records.
Yeah. So the index, we don't want to give any other name. So it's automatically takes, you're saying, right?
Like not any other name means
For example, if there is a big the employee data, so the indexing by the departments.
hmm.
So how do we do that? So we have to select from rows to one index particularly, or else like how do we indexing in SQL? Like department wise, I want to
like
do HR
like
department by HR
okay,
employees.
suppose you want to select a name uh, from student table or employee table. So are you asking is this enough to query, or do I
Mm.
need to write some more query to index and
Yeah,
get
yeah,
it the data so fast from the table, right?
yeah. To make index.
So so you do just this query is enough if you have already created an index using this syntax for that particular attribute. If there is an index, by default what it does is it first goes and checks on the index table. So index will also looks like a table, and if you have carefully seen, index will have a search key and pointer, right? Basically the search key, this is what the name which will be indexing, and this will go to a pointer. This pointer actually holds the address where I need to look up, direct straight to the way. If you have a table, you don't know where to look up, what it will do is it will go one by one, and it will go and find till all the records in your table, and it will match the name and it will get you. But in indexing, it will directly help you to get the access of that particular address, so that using this address will tell you where I need to look up exactly at this point or this point. So that's how the indexing works, right? So if you create the index using this syntax, it will automatically take care of that. You don't need to write any special queries for it.
For the indexing name, so no need indexing name
No.
also.
For name, in this case, I indexed name and address together. Okay,
Mm-hmm.
not separately. That you need to take a note down of. That's why I said it's a composite attribute. I indexed both attributes together. That means the indexing will look like it will take this as a unique value or this considers together as a single value. First, it will go and check in the name, then it will go and look at the address. That's the one good thing about composite key. And if you are indexing only based on name, this works for this index. But if you put address, this is not a good way of indexing name and address together. Because since it is name, we are querying the name. So by default, this index will look the name as a first attribute because that's how we indexed. So if you are putting address, so this indexing doesn't work. By default, it looks the name first and then it looks the address, this index. But if you are indexing only single attribute, then you don't need to work in it. Since it's a composite attribute, that means you are indexing two attributes together. Then you need to worry about the order of query. If you are selecting name and address together, fine. But if you are selecting address and name using specific where condition, then you need to we'll see how can we use efficiently index. These are the rules of indexing that we need to remember. So it has its own advantage and disadvantages also. When we are doing indexing, it doesn't mean that we are trying to access the data in a faster way. That's one of the advantages. So far, we have seen only the advantages of indexing. In last live session also, in this live session also, we have seen B3, B plus T, what are the various types of index, what is the advantage of multi-level indexing. So all this we have seen, but we haven't seen the disadvantage of the indexing. That we will just quickly go through using the 6 points. Okay. So the important thing is it will lead to the access and update trade-off. That means the if you are accessing faster, it will lead to update slower. Whenever you update something in your table, it will lead to slower updates. Is it why is it so? Can anyone think of it?
Sir, fast indexing required multiple layer of indexing, multiple layer, and for updating those, it takes time.
Like sir, if we use sparse index or if we delete the first the from which we recognize the particular set, so that number, so we if we delete that, so we have to make that point again, so that's why.
Yeah, that's the truth. If you are trying to have more indexing, multi-level indexing, dense indexing, also storage also matters. Since even though if it occupies less storage, but storage matters if you are not using the index properly. So the as you said, the indexing search key pointers also needs to be updated, and internally it maintains the B tree and B plus tree algorithm to keep track of all the indexings, right? So internally it maintains the B tree or B plus tree to access the particular record. If you are updating or deleting any of the record, the B tree and B plus tree should also be modified. And in order to modify the B tree and B plus tree, it takes time. See, consider if we have just taken a smaller example of B tree and B plus tree. If your B plus tree is so huge for 1,000 records, and if you have indexed all the 1,000 records in your table, it takes larger time to update your B plus tree, right? If you're even doing one modification, that in worst case I'm saying, but it may not be always. It's Are you getting my point? What I'm trying to say?
Yes, sir.
Sir, okay. These trees are only for maintaining the indexing record, right?
Yeah, yeah.
Okay.
So always you need to index the correct table. So you shouldn't index the wrong table. So basically, what are the tables which you will be frequently accessing, you should index that tables only. You should not index the unnecessary tables which you don't want to query often. That is true. And index the correct columns. You shouldn't index the wrong columns because indexing almost works in a ordered manner, right? If you are indexing based on unordered manner, there is no point of indexing. You should basically do dense index, which will have pointers to each and every record, and limit the number of indexes for each table. So as I said, you shouldn't have more indexes which are not required, since it occupies the storage also. And choose the order of columns in composite index. As I said, if you are indexing together name and address, you should be careful on which order you are indexing. So this order matters. And after that, what it says is gather statistics to make index usage more accurate. So once you define indexes on some of the tables and columns, so you should gather a statistics about how long my uh, how long the time it takes to access my record if I indexed it. Just a minute, I'm getting the call.
Sir, you're not audible.
Sir, you are explaining something? Hello?
Hello, sir, you're not audible. I think.
Yes, sorry. I was on mute. Sorry. Am I audible now?
Yes, sir.
Yes, sir.
So once you gather the statistics about the index usage, basically the time it's taking to access the record if you are indexing any particular attributes or columns. So once you gather that statistics, you might not require that index after some time. That's usually used to happen in practical scenarios whenever you have a production level database. Sometimes you might need to access often the table. Once you update your or upgrade your schema, you may not require that indexing no longer. So you might need to have the drop the indexes also. So basically, you should efficiently use this indexing. So proper columns on proper tables, and you should drop the unused indexes And also you have to remember this index will lead to this access and update trade-off. And the order of indexing, as you said in composite index. These are the rules which you need to remember while indexing before any table or before any attributes. Okay. So with this, we are done with indexing. So we'll move to the hashing if it is clear.
Could you repeat these rules again in a simpler?
So first is access update trade-off, uh, which is nothing but more if you are trying to access in a faster way, it will also lead to the slower updates and deletes since it's maintaining a B tree and B plus tree, and because B tree and B plus tree might have to do many updates and delete operation uh, to follow the B tree and B plus tree structure.
Okay.
And second is index the correct tables. Since even though if you are indexing also occupies some storage in your machine, right? So you shouldn't index the wrong tables which you don't require, which you won't be using it. So that's the point. And you should always index the correct columns, and you should limit the number of indices on each table because there is no point of indexing all the attributes in the table. See, your primary key is already indexed using the dense index one. So by default, the primary key uses the dense index.
Yes.
So you shouldn't index all the attributes like dense index or any other index which you won't require. That is the thing. And you should, if you are using composite index, the order matters. And finally, you should drop the indices which are no longer required. This will happen in, in a production level database because sometimes you might need to upgrade some features to your application which requires upgrading your schema, which will slightly change your schema, and no longer you will be requiring to index that particular table or attribute. So you might need to drop that indices which you are not using. And in order to make the indices in a better way, you should gather the statistics to make the index usage more accurate so that you can change the order of indices in a compose index, or you can drop the indices which are not required, or you can decide whether should I use primary index or dense index, multi-level index for that particular attribute. This will be helpful if you are gathering statistics about that index usage.
Okay.
Okay. So any doubts in indexing so far? B to B plus T, bitmap indices, and rules of indexing. These are very important for your exams also, and which is very important in practical scenarios also if you are designing any database.
Usually the B plus tree indexing all are using, or which one is famous?
B plus T.
Okay. So it is
Because the
basically
B plus T has a advantage of random access and the sequential access. Because whenever you access some table, sometimes it point the index already have as pointer to 7 or something. Instead of randomly coming and accessing, it will go to the next block and it will search in a linear way also. That's why B plus T is preferred.
okay.
Okay. Okay, then shall we move to the hashing part?
So last question. So we are B plus tree indexing we are doing. So it has given us a numerical. So in real life scenario, if it is schemas are given, how the index will be? We have to give the index in the sense like the department name as index, or how it in real time schemas. We are seeing the
Uh,
numbers.
yeah, actually, that's a very good question. By default, if you are indexing on alphabetics or alphanumerical values, it will take in an ascending order. That table should be in ascending order of that values, then only the indexing will be helpful. Otherwise, it again depends. That's why we are moving to hashing part alone. Sorry, hashing part also. So where we'll try to access using the buckets.
Okay.
Hello.
Okay. For
Hello.
hashing, I haven't updated my slides. So I'll use the lecture slides to explain. So whatever we have studied in lectures for hashing. So there are various types of hashing. We'll start with the basic static hashing. What's here?
Somebody was asking questions, sir.
I- Yeah,
Yes,
yeah, please go
sir.
ahead.
Sir, regarding this order of choosing the order of the this column,
Mhm.
could you please elaborate how will it help choosing the order?
How will it help? Like,
One of the point was choosing the order of these columns of the table.
hmm,
In the previous slide, sir, what you showed,
just a
indexing
minute.
rules, indexing rules.
Share my screen. Sorry. Yeah.
Second last, last third, sir, third last point.
Choose the order of columns in composite index.
Yes. So choosing the order of columns, how it helps.
Yeah. What it will happen is if you are indexing name and address together, and if you are trying to query select name from student table where id equal to something, or you are just randomly accessing, let's say, what it will do is, because in this case I haven't indexed name alone separately, I have indexed both name and address together. So if you're indexing together, what it will do is first it will check in the name column, the because the indexing also has the search key is based on together. So first it will go and search on the name column, then it will check on the address. Since you are selecting only name, this will efficiently work. But if you are only selecting the address, it won't work in an efficient way, since the index always needs to look for the name first before going to address. This won't work well. Okay. And also the order matters. If you are indexing in the order of name and address, so you should query in this order only. If you are querying in address and name, it again it doesn't work, because the indexing always looks for the name value, because this is the order which you have indexed. So first it will always goes and looks for the name, not the address. So the order of indexing matters.
Okay, sir. It has nothing related with the order of the table, right? Tree.
Hmm. Yeah.
This is not related to order of the tree, right?
No, not order of the order of the columns which you are indexing while creating this
Okay.
index.
I thought it is somewhere linked
Code.
to the order of that B tree, B
No,
plus.
no.
Okay.
Okay. I'll move to the hashing part then. So I'll try to cover as much as possible. So hashing part. So how many of you have taken PDSA course or already studied PDSA?
No, I didn't take.
Okay. How many of you already know hashing? Basic hashing. So no one knows. Can I assume no one knows hashing? Or
Yes, no one knows.
No, sir.
A basic idea of it, just.
I hope at least everyone knows what is mean by dictionary.
Yes, sir.
Yes.
Uh, Dictionary in the sense in Python you're saying, right?
Yeah, key value.
Yeah, key value pairs, yes.
Yes, sir.
Okay. Hash function, basically, here we are talking about static hashing. Okay. Right. The static hashing. So, so generally we represent key value using for a Python, right? If you take any key value, the particular value will be there. The anything, it could be A, B, C, or whatever. To specific key value, to specific key, there are specific values so that you could easily identify using the key. Hashing is also something uh, similar. So, but what we have is in between a hash function. We are introducing a concept of hash function, because using a hash function only the hashing works. So this hash function, as it could be any function, which we have studied in Max 1. It could be something like f of x or f1 of x, whatever. So it could be x modulo 8, x plus 1, or x square modulo 8. It could be in any form. Since I'm talking about the numerical values, I'm just putting x. Okay. So this is the hash function which will be used in hashing concept. So for all the keys, suppose let's say this is my x, which will be my key. Let's say I insert 1. This is my key, and I have hash function in between. So this hash function will decide where this uh, value should point to. So basically, this hash key will point to the bucket address. So if I put 1 modulus 8, it will go to the bucket 1. And if I put 2 modulus 8, I'm taking the first function. It will go to the bucket 2. And if I take 3 modulus 8, it will go to bucket 3. Is it clear?
So about the modulo function you're saying.
Yeah. I'm just taking as a modulo as an example here. It could be
It,
any hash function. So let's come to this point. Let's say these are the keys, random keys which they have given. So once this hash function, here they haven't mentioned what is mean by hash function. So once this hash function has been calculated, this John is going to the hash of 2, and this Sam is going to the hash of 4. But the problem with this hash function is something called collision. So if you find another key called 9, the 9 modulos 8 is what?
1, I think.
1,
1.
which we have already have and pointed to the specific bucket, or you could say the value, or also whatever. You do simple as remember, we'll see. Which it has been already filled. The value has been already filled using the hash function. But we are encountering another value for the same key, right? But where my value will go to now, since my one is already filled in that specific address. So what it will do is it will look for the next bucket where it is free. So 2 is not free, 3 is not free. So it will go and occupy this fourth part of the bucket. So this problem we call as a collision. So basically, where collision means where keys are not equal, but the hash values, which we represent h of k1, which is basically our function, is equal to, sorry, which is equal to hash of k2. So if you are facing this one, then it is called collision. Is it clear?
Could you repeat again, sir?
Uh, if you are having two different keys, basically your keys are not equal. In this case, 1 and 9 are not equal,
Hmm.
but your hash values h of k1 and h of k2 are equal here, right?
Okay.
This is also modulo 1, this is also modulo 1. So if you are facing this condition or finding this condition, then it is called collision.
Collision.
Okay. So that is what it is given here. If the two keys are not equal, we have the values that particular hash values are equal, then we call as a collision. But we don't need a collision, right? If you are having a collision, how can you find the specific key points to the particular bucket or address so that I can easily retrieve my record? Because if the collision has been occurred, what it will do is, if one has occupied this bucket, two has occupied the second bucket, 1, 2, based on modulo value. So the 9 modulo value will also point to this. But this bucket, assuming this bucket has a capacity of hold to only one record, what it will go is, it will look for the next bucket which is empty. So this is not empty, so it will go and fill up in the third bucket. And if you are finding a modulo next, if you are seeing the value of 3, this modulo value will be 3, it will go and see 3, but it won't be in 3, it will be in the 4, which is next block, which is 3. It will go and occupy this one, not this one. So this is the problem, we call it as a collision. But ideally, we don't want a collision to access the records in a faster manner, because again, this leads to some access trade-off where it needs to go and look for the next bucket if it is there or not. So basically, our hash function should be collision free and fast. So in order to solve this, we'll see the dynamic hashing, how it works uh, with the fixed record. But this is a simple hash function or hashing concept, which I can explain right now. Is this clear? Which is also being covered in previous year, I guess.
Yeah, excuse me, sir. One thing is not clear. In static hashing, we cannot avoid collisions, so it is not practicable. Or the fact is that something can be done to the collisions. I could not understand this part.
So we cannot avoid collision. That I can say true, but it also depends on the hash function that we are choosing. Because if you are choosing simple hash functions, uh, which might lead to get the same value for 3 or more different keys or n number of keys, that means your hash function is not good. The hash function which you are choosing is not good, and you can choose a hash function in a such a way based on the current records. You might, or you can come up with a good hash function where you cannot face any collision. But in future, if you are updating any values in your table, that might lead to a collision.
No, my question is, if it has a collision, then is there any way out in static hashing to point to the hashes, or we have to
Uh,
resort to dynamic hashing?
that we will see. There are some more things which we have to cover in static hash. Okay. So in static hashing, there is something called a bucket. As I said, a bucket is a unit of storage containing one or more records. So all this key, where it will go and point is, it will go and point to the bucket. This bucket will be having a limited capacity or fixed capacity to hold particular n records. So if you say the bucket has two records, it will have the one bucket can hold only two records only. The one and if you are saying the bucket can have three records, each bucket can have three records. So again, the problem will come. Let's go see one by one. So then you might understand what we are trying to reach. Then we'll finally reach dynamic hashing.
So the hashing, it must be like in modulo or else any other function also.
Sorry,
The hashing function, it must be in a modulo function or else any other function also, or different kind of function.
it could be any kind of function.
For example, you said modulo, any other function?
Yeah, any other function. Even it could have x plus one, x square plus three, x square power two or three. Any function.
Even a mod function will suffice. Mod
Even
a mod x or parabolic function or exponential functions will also suffice.
yeah, any function. That is up to us based on the records or the keys which we have. We need to decide a optimal hash function,
So that
which we are
means
not covering here. Okay,
okay. That
so that's depend on us which where we need to choose a optimal function. So in such a way, at least we should avoid a collision. But at some point, collision might happen if you are updating so many records in future.
Okay, okay.
Okay. So this bucket is clear, right? So bucket is basically it holds the not actual values. It holds the pointer to the from bucket. It will hold the pointer to the actual records.
So it is
So
it is
bucket is a
like
unit of storage containing one or sorry.
it's a
Bucket itself can
two
contain
by
a record. Sorry.
values you can say. So for example, modulo, if it is a 35 modulo 5 means it's like 0.
Hmm.
So that 0 is a bucket, you say, right?
Yeah. Zero is the bucket. Zeroth bucket. So it will hold and store that particular record.
Yeah, all the fives, fifth dividing
And if
five.
you
Yeah.
so this is what we call as a hash file organization using the hash function. But we'll see the example. One of the example here. Here, assume they have given there are 10 buckets, and this is the hash function which they have already given. For example, if you are finding any music department, so that will go to the first bucket. And if you are finding history, it will go to second bucket. If you are finding physics, that will go to third bucket. And electrical engineering also goes to third bucket. Again, the collision is there here. If you see here, there are two different keys, physics and electrical engineering, and it points to the same value, which is collision. But here, at least we can somehow overcome this because of bucket size. Okay, because here in this example, we have taken a bucket size equal to 4. You can see 4 empty rows are there in each record. Sorry, each bucket. So since we are having a 4 uh, as a capacity for each bucket, so we are not having any problem with collision, at least here. If you are having a bucket size with only one, what it will do with this collision? So this electrical engineering, instead of storing it in 3, it will go and store it in fourth bucket, right? So by default, whenever there is a collision, it will go and look for the next bucket, whether there is a free space or not, it will immediately and occupies the next bucket.
Sir, in that case, the number of keys equals to the number of buckets. Then what is the point of having the buckets? Then without the bucket itself, the same thing would have
But,
occurred.
but Yeah, but how can you find such kind of hash function? That's my question.
Yeah, actually,
You,
I want a hash function to reduce the thing and put it in one bucket. Now, again, in one bucket, if there is only one entry, then what is the point of having a bucket?
then there is no point, but I'm saying as an example. So even though here we have inserted at least around 10 records, I guess. Suppose there is a physics here, which I have inserted one more records. Now I wanted to insert electrical engineering. The record has a department called electrical engineering. Now my bucket 3 got filled, right? So where this record will go and insert? It will go and search for the next bucket. If there are any empty spaces, if there are empty spaces, it will go and occupy this. Suppose now if you wanted to query the department called electrical engineering, instead of going to bucket 3, it also goes and search for the next bucket, which is typically takes extra time to find your records, right? So this is what in X slide they have given. A worst hash function maps all search keys values to the same bucket. This makes access time proportional to the number of search key values in the file. Okay. So the ideal function should be random so that each bucket will have same number of records assigned to the irrespective of actual distribution of search keys. So basically we should avoid a collision, right? And the bucket size can't be changed. Once it is fixed, it is fixed. That is why we called as a static one. So bucket size also we should uh, choose wisely. Any doubts so far? In there is a concept of overflow bucket. So far we have seen in perspective of collision. And now we are introducing the concept of overflow bucket.
So how the collision happens?
How the
The collision you're saying like how it will happen.
hmm,
Example.
example? I have shown the example right here. Here both departments have value same 3. That means that is a collision. For two different keys, if same values are there, that is a collision, right? See, same value, but two different keys, physics and electrical engineering.
Okay, what is trying to say, sir? So it will put it in the same bucket you're saying.
No, if collision occurs, it might go and store in next bucket. So that's the basic concept which we have studied in PDSA. Those who have studied, I think they might know. It may be possible if your bucket size is too low or if your bucket is already been occupied with all the records.
It's a bit confusing, sir, because the collision part. So it starts with from there. So collision in the sense what I understand is the different key and having a same number of rows
Value,
here, values you're
same
saying.
value, same
Uh,
value.
means what, sir? So music one, history two, physics three, and electric. So what is trying to say? It's having a three records you're saying. Same records. In physics is electrical. Is it correct?
Can you repeat again the last part?
The records is three and three you're saying. So that is a record, or else a row we can say that.
This is not the record. It's the value which it is having here. It points to the bucket number.
Okay, so
Hmm.
three buckets, and this is three buckets, two buckets, one bucket, right?
Hmm. If you see carefully, this physics and electrical engineering are in the bucket 3. That is what it is
Oh,
saying. So this physics department should be placed in bucket 3. This electrical engineering should also be placed in bucket 3.
Okay, okay. It's pointing the same buckets you're saying.
Yeah.
Okay, okay. Now got it. Now got it. Yeah.
And if you are trying to insert two more blocks which has physics, so you won't be having a space to fit those two
In
records
static,
which will have
yeah.
physics in bucket
Different
3, right?
four rows we have, so we can't do.
Yeah.
You're saying.
So where it will go?
Next bucket,
Four.
bucket 4.
So by default, this is the concept which we have studied in PDSC. By default, it will go to next bucket and it will occupy the empty space if it is there. So now we are coming up with a concept called bucket overflow. If there is no space in that bucket, we are coming to a concept of bucket overflow. This is okay.
Sir,
So
hello,
if all the suppose let's say this bucket
hello.
one,
Sir, I have a doubt.
yeah, let me complete this bucket overflow first.
On this previous topic.
Yeah, I'm coming to that only. Let's say this bucket one has 4 as a capacity. If 4 buckets has been filled, what it will do is it will go to the
Next
next
bucket.
bucket. Basically, in that particular bucket, it creates another bucket. So, in the physics and electrical engineering, this let's say the bucket 3, it has physics and electrical engineering. And maximum it has a capacity of 4, only one is empty. If you are inserting two buckets, sorry, two more records, one will go and occupy here. So one more where it will go? Instead of going to the fourth bucket, it will create a
It
new bucket and it will point to the new bucket and which will also have 4 records and it will occupy the particular record here, electrical engineering.
Sir, in bucket zero, the buckets are filled or empty.
Hmm?
Bucket zero is full or empty. In this case, why? Because why we not create extra bucket alongside alongside on bucket zero? Means
Alongside.
beside be create for bucket one extra bucket. Why?
Hmm.
Why you want? Why you want for bucket zero?
Because my bucket is not yet filled. My bucket 0 is not yet filled. If it got
Okay,
filled,
okay,
then I
okay,
need to create a new bucket and it will come to the
okay.
overflow buckets.
So those buckets are filled. We create for those. Like,
Hmm. And if you see in overflow bucket, all are linked again.
ha, ha.
So if you are finding the hash key equal to 1, this is also equal to 1, and this is also equal to 1. So if all my bucket 1 is got filled, so it will go and look in my overflow bucket.
So
Um,
this comes open hashing, na?
Yeah. No, this is closed hash.
Through hashing.
Open hashing doesn't use any overflow buckets.
Hmm.
So the bucket overflow, is it clear or not? So bucket overflow will occur only
yes,
if
sir.
there is
Yes,
a
sir.
insufficient bucket and if there is a skew distribution of record. This is again, as I said, multiple records can have same search key values and choose an hash function which is not your optimal hash function. Because of that, this overflow bucket will. One is insufficient bucket, which is mean the bucket size is too slow or your bucket, the number of buckets which you are having will be very less. That is one of the reason. And the second reason is multiple collisions occurs. Basically, the multiple records have the same search key value, which is your hash value, and also due to the hash function. So that's why I said you have to choose a hash function wisely. So because of these reasons, the overflow bucket might have.
So, also forgot is desirable or harmful?
Is it?
Is it desirable or harmful? Overflow buckets.
Everything has its own advantage and disadvantage. Now we using the overflow bucket concept. At least we came out of the problem of collision, right?
Hmm.
It's
Okay.
still the problem with overflow bucket is still it occupies the more storage because we don't know how many buckets we want. And whenever it creates a overflow bucket, the search gets more time because it needs to look for the next bucket. If the next bucket is also not found, it has to go and look for the next bucket. That's something which we can't avoid. It might happen if you are having large number of records. Okay. And the problem with the main problem is the storage. In the static caching, you have to fix the number of buckets in early. If you say 8 buckets, there should be exactly 8 buckets. You can't increase or decrease the number of buckets. So even though in your bucket, if you are not utilizing all the buckets, all the records, the storage will be dedicated to that bucket. Even though if you are not using, the storage problem is there in the static hash.
Sure. Hello.
Hello.
Sure. Can you hear me?
Is
Hello.
it clear?
Hello.
Yeah, Sudhir, you are audible.
Sir, I have doubt in this previous collision part, right?
Hmm.
If the values are same
Uh-huh.
for the two keys, then only it is going to be a collision, right?
Yes.
Suppose, as you explained that in the case of the electrical engineering and physics,
Hmm.
if that bucket fills, then the next thing goes to the next bucket, right? And
Yeah.
what if the other buckets?
Okay, that is in case of collision, but in order to avoid collision, we are coming up with a concept with overflow.
But sir, collision is only for physics and electrical engineering, right?
Yeah, but it might occur in few other subjects also, right? If your
If
hash function is not good.
sir, suppose if the values are different, keys and
Hmm.
values pair are different for the other buckets, and if that bucket fails, then what is going to be?
Like if the keys and values are different.
And the entries are going to be filled in those buckets,
Hmm.
then is it going to be shifted to next bucket or?
No, it won't shift as long as you have enough space in your bucket so that it holds that particular number of records. If you don't have particular number of records to store in your bucket, then it goes to the overflow one. That's it.
No, sir. Still I'm not clear.
So what you
I'm,
are trying to say? If
you,
all the
you
or if
explained
all
two
the
things.
keys are if all the keys are unique,
Sir, could
this
you
is
please
what
go
you are
to the
trying to say.
previous page where you explained collision?
Here.
Yes, sir. Sir,
So
first
what?
you explain the collision for this
Yes.
electronic and electrical engineering and physics.
Mm,
You are saying that the keys are different and value is same. So this condition is collision, right?
mm.
So if bucket 3 get filled, then things go to bucket 4, right?
That was our initial consideration before we are studying overflow bucket overflow concept. Okay.
In this
So
condition, is
mm,
there a consideration for overflow bucket for bucket 0?
bucket zero, since my bucket zero is empty, I don't need to create another bucket that points to the overflowing bucket, right?
No, sir, that is my doubt. That suppose the entries are such that
Okay, that
even,
suppose you are saying the entries are full here.
yes, even after that, the data is such that even after the collision, this bucket 3 won't get filled and bucket 0 get filled, then what will be the situation?
I'm not getting the bucket bucket three is full and the bucket
This is
zero is also full. Okay.
okay.
And if you are finding a record which points to bucket 3, then what it will do is it will create another bucket from bucket 3 which is your overflow bucket, and it will store the record here.
No, sir, but this is the condition of collision, no? So you are saying that it will go to bucket 4.
See, that was the basic concept of hashing, I said. Okay. Since we studied the concept of overflow buckets, what it will do is it will go and create a new bucket inside this bucket 3, and it will store it here. It won't go to the bucket 4. I think, is anyone having doubts here or same doubt? Is it confusing?
Sir, there was a problem of collision, so we moved to the concept of overflow bucket, right?
Hmm.
Uh, in this concept only. Suppose there is a collision for the two keys values pair, right? Suppose
Hmm.
bucket 3 have two values pair same, that is for electronic engineering and this physics, right?
Hmm.
If condition is such that this bucket 3 is not filled, where there is a collision, right?
Then in that case, you won't be having any problem as long as the bucket size is
And bucket
available.
and
Then you won't be facing any problem in terms of collision. Suppose let's say if your bucket 3 has a size of 10 so that it can hold 10 records, even though if you are having collision with 3 or 4 departments, let's say uh, you are having a collision with physics, electrical engineering, chemistry, and mathematics. All 3 points to bucket 3, and you are having only total of 6 records across all 4 subjects. If your bucket 3 has a size of 10, so all 6 records will be stored in bucket 3 only.
so we don't have any problem. And
Yeah,
suppose
we won't be having any problem.
and in that condition only if bucket 0 is not having any collision and records are filled.
Bucket 0 is empty, right? Why you are touching the to bucket 0? If my value is not 0, then you don't need to touch bucket 0, right?
No, sir. Suppose if there is situation that bucket the values for bucket 0 is filled where there is no collision, then
Okay, so your
what
bucket 0 is also filled.
and there is no collision for that
So all
bucket.
this is got filled with some records. Okay, no collision. Okay, that means all will have a subject called what subject I can say.
Then what
Let-
is the condition for next entry? That is my question.
For next entry, based on which entry, it's that also matters, right? If it's a same entry, like
Yes, sir.
let's say the example is
For same value,
D,
key value pair.
DBMS for bucket 0. If you are trying to insert the fifth record in bucket 0, which is not available here, the fifth record, then it will go and occupy the DBMS in the overflow bucket.
Okay, sir. Thank you.
Okay,
Got it, sir.
okay then. Then this has been computed using the one of the example using the bucket overflow concept. So these are the ID numbers. So here the hash function is calculated using the computed by adding the digits by modulo 8, which is nothing but you add the individual digits 7, 6, 7, 6 plus 6. Then you sum up, then it is nothing but 32. And finally, you have to take a modulo of 8, which is 0. So that's why it is stored in bucket 0. Similarly, if you take sum up and add all those numbers, then it will point to the corresponding bucket. This is the hash function they have given as an example. So this is nothing but an instructor ID, which is nothing but. So in bucket 3, bucket 4 is empty because we haven't found any numbers. They haven't given any records also. Okay. So the bucket 4 is empty because this instructor IDs doesn't have the modulo 4. But in this case, if you see the 151, which will have a sum of 13 modulo 8, which is 5, and 3, 3, 4, 5, 6, which is 10, 18, 21, again modulo 5, again 5, 8, 5, 8, 3, which is 29. Again, sorry, this is 8. Again modulo 5. But my bucket 5 has a size of only 2, which has been already occupied. So what it does is, it creates a new bucket, it points to that, and it created a new bucket, and it stored that 58583 in that overflow bucket. And it points to the corresponding record. Is it clear or confusing
Yeah,
still?
yeah, yeah. So it creates, you're saying even though bucket size is less, so it's create a new bucket as same, and it's pointing there.
So this is nothing but a overflow bucket here. So this is a overflow bucket for bucket 5.
Also, sir, in the database we can't fix the bucket size, no, because it depends upon the what the rows depends upon the index, right?
No, we have actually the bucket size is fixed in static hash.
Yeah, yeah, but
Here we are assuming all the buckets will have only size 2.
okay, but in if it is a departments in HR departments less people and operation departments more people, how will you
Ah,
segregate the bucket fixed bucket? Because we can't say the less
that's
people. Uh,
the problem with static hash, because
yeah,
the static means what? You already fixed everything. Just you need to work based on whatever it is there. You already fixed the number of resources which I am gonna use. You doesn't care whatever the records or rows are there. So once you fixed, you anyways you have to work with that. You don't have any choice with it. That's called static hashing. That's the word denotes static, right? You can't change anything at uh, at any point. Once
but
it is fixed,
anyhow
it's
you are
always
saying
fixed. You have to work based on that.
anyhow you are saying the overflow bucket, no sir. Then it's creating a new rows also. Then what is the issue, sir?
The issue is the addressing. If you are trying to access, for example, here, okay, if you wanted to access a record, Calipari history, which is 5853. So first, what will it do? 5853. It computes a hash key which goes to 5. You will go and search in this bucket whether 5853 is there or not. We
Yes.
haven't found. It will go to the overflow bucket and you found 5853. Suppose for example here also you haven't found 5853. So it might
The next
be
bucket.
in next overflow bucket.
Okay.
Again, suppose in here also if you haven't found, it might be in next overflow bucket. The accessing time takes a lot, right?
Mm-hmm.
That's the problem with this overflow bucket. Anyways, we can't avoid at some point the overflow issues, but that can be minimalized using the concept of dynamic hash.
Okay, sir. Okay. But for this kind of hashing, no, we are giving any function in the database. We can't do usually the roll number from the department wise. It may vary.
Hmm.
Can't do any proper as function, no, sir. In modulo or any kind of function. What function we can give for action? This is fine. Anyhow, it is different. And for example, I want a department wise the bucket. Okay.
Mhm.
So it having multiple rows, 1,000 employees. How can I do the hashing in that sense?
Based on department.
Ah,
So either what you can do is in that case, either you can set your hash value based on uh, hard coding. So for example, electrical engineering should go to this bucket, physics code should go to this bucket. That is one
okay.
of the option. Or either you have to compute a hash function using the string values. So every string has some values if you encode it, right?
Yeah,
ASCII values.
ASCII
So
values.
using that, you might encode, or you can come up with a hash function that uh, exactly uses the string to encode and gets come up with some values. That
Okay,
could be
20.
any kind of hash function. It
Okay,
doesn't
okay.
matter. It always shouldn't be like only I can handle numbers. It could be any hash function that it can handle strings also.
Okay, now got it. Okay.
Okay. So and this is called efficiency of static hash. As I said, so search key values in a fixed set of bucket. That is one of the problem. If the database grows or shrinks in a time, the performance option is there due to too much of overflows. As I said, if there are too much of overflow bucket, the performance will degrade. The access time will take longer. And if the space is allocated for anticipated growth, a significant amount of space will be wasted. That means here the bucket 4, even though this bucket 4 has not been utilized, we are wasting the bucket space here, right?
Yeah.
So that is the point here. If database shrinks again the space will be wasted. For example, if you delete the sum of the records from 1,000 records to 100 records, you have been deleted, which previously that 100 records pointed to some buckets and hashing. Now, since you have deleted that 100 records, the bucket will be empty and the buckets will be still using that space. So there is a problem with if database strings whenever you delete something. And you might need to, the solution is you might need to periodically reorganize, you need to periodically have to give new hash functions, you need to recompute buckets. That is not good, right? If you are doing every time whenever you delete some records. So
Mm.
that is one of the solution, but that is not good. The better alternate solution is allow the number of buckets to be modified dynamically. That means don't create a bucket whenever you get a demand. So for example, in a static hashing, these 7 buckets are fixed. You cannot update or delete. That is called static. But in dynamic hashing, whenever you insert a row, then you create a bucket. If you don't require a bucket, then you don't create it. So whenever you delete, the bucket will also be get deleted. That is called dynamic. So
Sir,
is it
sir, I have a problem here, sir. Sir, in case of dynamic buckets, the space of say two buckets increases by twice the number. So in the lecture, sir said somehow we can fix that up. Means if the requirement is for just one entry, then we can fix it. But exactly, I could not get how is the fixing done.
not getting where you are referring?
In case of dynamic bucket, when one bucket overflows, we create another bucket. Now that
Okay,
other,
you are talking about dynamic bucket,
yeah, yeah,
dynamic
so,
hash.
yeah, yeah.
Okay, I thought you were talking about static hashing. I'm thinking where you are referring to.
No, no, no. I have gone through it. The date of, I mean, the submission is pretty soon. That's why. Yeah, I could not understand that when there is overflow, I'm creating a bucket. Now, in that bucket, if I create another bucket, you are creating twice the space, while you are actually requiring only one entry. So there is a way to solve it in the lectures. They have told it, but that I could not get.
Mhm. Okay. I'll quickly go through the dynamic hashing. I hope everyone is clear about static hashing at least.
Ah, yes.
Does anyone have any doubt in static hashing before moving to dynamic hashing? Shall I take it as yes or no? Since
Yes,
everyone is sharing.
Yes, sir.
Yes, sir, we can proceed.
yes, sir.
Okay. So dynamic hashing, what I will do, I will just quickly go through. I won't explain line by line. Uh, since we already ran out of time. So this can be covered in one of the revision session also, or you can watch a previous term lecture. Generally, we won't ask dynamic questions in the end term. So I'll just quickly go through. If it's required, we'll cover in the revision session. Okay. So the extendable hashing, which is nothing but a form of dynamic hashing. So this we do based on the bits here, the number of bits it requires. So based on the bit, we'll compute the number of buckets. The bucket will be dynamic. So you have to remember this. The bucket will be dynamic, but the bucket size will be fixed. So due to bucket size is fixed, there might be a problem again the overflow bucket which we can't avoid. So since the bucket is dynamic, bucket can be created and deleted whenever it requires. But whenever you create a bucket, the bucket size is fixed. So due to this, the overflow bucket can occur in dynamic caching also. But compared to static caching, the overflow bucket will be problem will be very less compared to static caching. That's it. So this is how the based on hash prefix, this is how we used to do. So this is based on the two hash prefixes, which is 0001 1011. So the buckets still, if you see, there are four hash prefixes, but still we have only three buckets because it's creating the buckets based on the need, not based on the number of hash prefixes that we are doing. Okay, so we'll quickly go through the example, then we'll end up this session. So I'll take this example. So this is the hash value of those departments: biology, computer science, electrical engineering, finance, history, music, and physics. So these are the hash values, these are the hash prefixes, and the leftmost bit, which is these are the leftmost bits, which we call as a significant bits here. So let's go to the example directly. So initially my hash prefix is 0, which is my bucket address table, which is this bucket. So my bucket size is fixed here, 2. And these are the hash. Let me zoom it a bit. Yeah, zero. So the bucket size is fixed. These are the hash prefixes that we have seen. Now we'll be inserting these records in my hash prefixes based on this hash key. First, what we are doing, we are inserting Mozart, Srinivasan, Wu. If you take a Mozart, he belongs to the music department. The music has a hash prefix of 0. So I can insert here, no problem. Music, Mozart. I'm just writing it. I'm not writing it fully. So next row, I want to insert Srinivasan. Srinivasan is a computer science department. To take a leftmost significant bit, which is 1, uh, which is not 0, so I don't need to worry. So what I will do, will create a hash prefix which points to 0, 1, and this will go to my bucket 2, and this will go to my bucket. Where can I go? Aeronautics. Will draw my bucket 2 here. Don't mind. So this will be will be having computer science with Srinivasan. And the next row, which is if you see here, finance. So can I fill finance in any one of these bucket? You see finance is 1. So finance, this bucket address has 1, and in this bucket, which is bucket 2 here, am I having any empty space here?
Yes, sir.
So I can, using the 1 bit alone, using the first bit alone, I am able to address that bit, and I'm able to find the empty row in my bucket. So I can fill finance. I got it. Okay. So after inserting this, my hash prefix table will be this. So which has the hash prefix 0, 1, and 0 pointed to here, 1 pointed to here. So I just use it only 1 bit, only first bit, since I'm having a space here. Okay. Any doubts here?
No, sir.
No. Okay. Next, what we need to do is we need to install the Einstein record. So if you go and look at the Einstein, which is physics department. So in physics, the leftmost bit, which is the first bit, which is 1, and which points to the bucket address 1. If you go and have a look at it, the bucket 1, sorry, it is bucket 2, which has the bucket address 1. It is already filled, right? Which is already filled. So now I need to create a new bucket. So in order to create a new bucket, I need to extend my hash prefix. So it will be 0, 0, 0, 1, 1, 1, 1. So this is how my hash prefix will be now. Okay.
So one
Sorry.
zero one
Oh,
one.
sorry. Okay. So now I extended my hash prefix. So now I need to address the new row by considering 2 bits, because I'm not able to find any empty space in the existing bucket. Now I need to address using the 2 bits. If you take a look at it, the physics department, so it is 1, 0. So where it will go is, it will go to here, physics. Okay. This will create a new bucket. But what will happen to the existing rows, which I already placed in some of the buckets? The computer science and finance. So you need to consider 2-bit prefixes for the already inserted record also, where it has been clashed, or where we couldn't fill that in that bucket, because initially it was 1. We have considered 1 bit. By considering 1 bit here only, we are supposed to fill. Since we are not able to fill, we extended the hash. And here, for both this, we need to consider 2-bit prefixes. So for computer science, the 2-bit is 1, 1. So it will go here. Computer science will go here. And for finance, the hash prefix is 1, 0. So along with physics, the finance will also be there. Since we haven't done any changes here, because the problem came when we tried to insert uh, physics using the 1-bit prefixes. So we split it and stored with other 3 buckets. So this 2 hash prefixes still will point to the same bucket, and which will have only one record called music. So after inserting, my bucket structure will be like this. Any doubts here? How I split the bucket?
Yes, sir. I don't understand this.
Where you are not able to understand?
How did you split, sir? In first only, because like, how did you put it in computer science and finance in a one particular one table in one
Hmm.
bucket, and after
So when
you
I
put,
try to insert finance, Einstein, sorry, physics, this physics, if I consider one bit, because earlier we considered one bit as a hash prefix. So if I consider one bit where it points to my bucket, this bucket 2, and it doesn't have any empty space. I couldn't fill anything, right? So because of this, I extended my hash to two prefixes as 00, 10, sorry, 01, 10, 11. So because of this, I extended. So now I'm considering two prefixes. So now I'm inserted this physics considering two hash prefixes, which is 10, I inserted. And the existing prefixes, sorry, the
Mhm.
existing records, which has prefix 1, right?
Yeah,
That also I need to consider using two prefixes. No, because using the 0 prefix, I don't had any problem. While inserting the hash prefix using 1, I had a problem because I need to consider two prefixes. That's why I'm reconsidering this computer science and finance using the two prefixes, and accordingly I'm computed and stored in the buckets.
because computer science one and physics finance is 10, and you are changing it, right? Okay.
Yes, yes.
Considering two prefix. Okay, okay.
So wherever I have a problem, I need to insert the new record using that extending physics to physics. Then I need to recompute that existing records also. Since I don't have a problem with 0 prefix because I haven't touched anything in the 0 prefix. So while inserting using the 1 prefix, I had a problem. I can't insert, so I need to recompute that 1 prefix also. Getting my it takes some time to understand. I'm getting it, but at least as of now, is it clear or still
No,
confused?
no, getting
Sir,
it, sir, because
please beg your pardon, sir. I could not.
Uh, okay. Where you are not able to understand?
No, the whole thing is a bit.
The
so,
whole
so,
thing.
so that actually, whenever the new records comes, and we have to compare with the prefixes, and we have to change it accordingly. The buckets, right? You are saying.
Yeah.
Yeah, yeah. Now my question is, suppose I change the prefix from was means I'm taking the second prefix. In this way, I continue up to how many prefixes we have? Four plus four. I don't know how much. Say 32. In case I do finish all the 32, then what do I do?
You can't uh, use dynamic buckets anymore. Then you have to go with overflowing buckets because this hash prefixes will be fixed with this hash prefixes will be either fixed with 32 or 64. If you are using all 32,
Hmm.
then you might have to go with overflow options. Here in this consideration, we'll take max of 3 prefixes, then we go to overflow uh, for an example.
Means
But in real cases, if you are using all 32 prefixes
hmm,
and having all the dynamic buckets,
hmm,
still you are facing a problem with the bucket where you couldn't insert. Then
hmm.
you have to go to the overflow option. That's why I said dynamic hashing can also have a problem of overflow bucket. But it is very less, right? Considering 32 bits or 64 bits, the overflow option.
Yes,
No,
sir,
point is
it is
that
not
suppose
possible.
yeah, it's possible in the sense that some great company like Google, Amazon,
No, no, no. It's not
or
possible
or
because
some.
if it is a huge, you have a bucket size increase, and
Yeah,
this
yeah.
much
That
prefix
also
also.
depends on the bucket size, the number of records that you're gonna
Uh,
have in database. We
Yeah.
are dealing with a small number of records to see an example how it works.
No,
Right?
in
that
real life, if there are some great companies using this, then how do they deal with this problem? By overflowing only, and there is no other way.
for example, you take the Aadhaar card only 12 digit only, but everybody having unique, right? Like that,
Hmm.
64 bytes.
Okay, that's for India's just identification number. Now, say for example, the whole world, something United States climate control or
64 bytes.
something. I
64
mean,
bytes.
that is also true. Yes, might be means the whole world UNO or something. No, that also does. Yeah, might be. Yeah.
Mm.
Yeah, what you asked, I forgot. You said you are having doubts here.
Yeah, now it's clarified. Thank you, sir. Yeah.
At least I'm very happy you are comparing with real world databases. And at least you're able to come up with a scenario where it can be helpful.
Yeah, actually, say in ChatGPT, I am writing something. The whole world is writing something that in that state it is taking up. I don't know what, and then it's also managing. Means even the SEO engine of Google or some everything, even your perplexity which we use, everything. So they are happy with just this much only, or we can have something. Billions of entries would be there in ChatGPT in a second or
Yeah, that's another topic of debate. I just don't want to do now. Actually, there are various kinds of database, not just this form of SQL. Right now, what we are seeing is a RDBMS, which is a relational database, which is managed in a tabular form. Okay, that is one of the database. There are other forms of database which is called NoSQL and which doesn't have any structure.
yeah, even
Uh,
MongoDB has I mean, it is meant to be of unstructured data. MongoDB itself, right?
yeah, there is a MongoDB which is unstructured. That is one of the example.
Yeah,
And Redis that is having key value. That is
yeah,
one of the example. And
yeah,
Google has its own database based on tabular within tabular. That is one more.
yeah.
And
And
right
the
now,
Google,
graph
if I,
graph databases are there. So
yeah,
it's another topic I don't want to go on. But
okay.
understanding RDBMS gives a solid concept of how databases work.
Okay. Okay, sir, one small question. Actually, I've, see, SQL you can learn in 3 days, but if you don't put, you will forget in another 3 days. Now, the point is that once I had read SQL and SQL only, did a project on SQL in which the different queries I had written 5 to 6 queries, out of which two of them ran on one table. I mean, one I mean, what was that called, database, and the others were on that separate database. I could run it from a keyboard entry, not from the mouse. I select everything and execute. What was the shortcut I used in the keyboard to run the whole query? Because I shifted the database also. First two were in one database, the 3 4 5 was in a different database. I used the keyboard, but the what I used in keyboard, which I have forgotten.
Are you talking about the PG admin?
I'm talking about
Are you talking about the PG admin, SQL editor?
P A PGM. What do you mean by PGM?
PG admin, where we used to write queries in week 2 and week 3. Postgres.
Oh, Postgres. No, at that time I used very similar to Postgres. I think MySQL or something similar. It's
Mhm.
same thing.
Okay. I haven't used MySQL editor, but all
Oh,
the SQL can be written in command line also. That is true.
yeah,
But
yeah. How to do it even in Postgres, whichever. I might get anything in my workplace, and I have to look up that much. But Is
And there is a shortcut in Postgres. If that PG admin, it has a function F5 to run all the queries.
sure, just press F5, right?
And if you want to specifically select and run particular query, then you have to select using that particular query using the mouse. Even though if you have many queries, then press F5 after selecting the query code.
Okay,
That also works.
okay. Thank you.
Okay. After this, since this is how my record will be, then if you insert gold, then again physics. Since we are considering two hash maps now, it will be 0 1 1 0 1 1. So physics again it is 1 0. Now I don't have a space again 1 0. Right. So what I will do, will extend my hash prefix to 3 0 0 0 1 0 0 0 1 0 1 1 1 0 0 1 0 1 or 1 1 0. I forget the order. Uh, Pardon me if I've written in wrong order.
Yeah, it's
So this
correct.
is how hash prefix will be considering 0 0 0 0 1 0 0 0 1 or 0 1 1 or 1 0 0 1 0 1 1 1 0 1. So what we did is we inserted gold, which is physics. So if you see the gold, which is physics, now we taken a 3-bit 1 0 0, which is gone to this physics. And whatever the existing rows which were there, finance and physics. So for finance also I should consider 3 prefix now. Then it is 101. So only for specific this bucket I'm doing. I'm not taking 3 prefix for this or this because I found a problem while considering 2 prefix while trying to insert in this bucket only, right? So whatever the records which were earlier in this bucket, so I should consider 3 prefix for that also. So for finance, if I consider 3 prefix, it is 101. So it will go to the bucket of 101. Okay, I written correctly only 101. It will go and look, store it in the finance. The remaining one, as it is, computer science, it is there, music, it is there. And while trying to insert LZ, which is belongs to history. And history has also the problem with 1 1. Okay, using the 2 bits itself, I'm able to find, so I don't have a problem with since 1 1 as a empty row in my bucket, I can insert history here. Okay. So I don't need to consider 3 bucket. Sorry, 3 hash prefixes. So this is how my final structure will be. So after inserting again Kate's record, Kate's is where computer science. Computer science is again. Uh, so far I addressed using 1 1 only. So since this, so this number denotes how many hash prefixes I use to address this. If it denotes 1, only hash prefix 0, the first hash prefix I use to address this. If it is 3, 3 hash prefixes I used. If it is 2, I use only 2 hash prefixes. So if I wanted to insert computer science 1 1, again the problem is computer science won't be inserted here using the 2 hash prefixes. So I should consider 3 hash prefixes. So the computer science is 1 1 1 triple 1. So the computer science will be still there be in triple 1, but the history hash prefix is 110. So this 110 will point to the new bucket now. This will have history, and here instead of history, computer science will be. So by considering 3 prefixes, if you see. Right. Is it clear? So if it is clear, then I will go back to final step. So
Yes,
it's
correct.
already over time. Everyone left. Is it clear?
Yes, yes.
Yes.
Then finally, uh, after inserting the okay, this is the final step. After inserting this sing calipari crick. So to take an example, as I said, hash prefix can go up to 32, but in order to show the example of overflow bucket, we fixed the hash prefix to up to 3 here. so that we can show an example of over prefix. So finally, for inserting the record, what is that record? Brand, which is my final record. So the brand record, I'm not able to insert here. So 1 1. So which is my computer science department for brand. So since I limited this hash prefix to 3, so as I said, it might go up to 32, but as I limited, so I might need to use overflow bucket, then I need to store brand here.
So
All
we need
this
to
meaning otherwise.
limit that bucket also. Like, don't go to more than three prefix. You're saying.
Yeah, I limited, especially since I need to show the example of this overflow option. But if you're extending to 4 prefix, then it won't go to overflow bucket, it will create a new bucket. If you are
Yes.
4 prefixes, then it will be 0 0. Then you
Yes.
can consider up to 4 prefixes, 1 1 1.
Yeah. Yeah.
So I just wanted to demonstrate overflow bucket. That's why I limited to 3. That,
Okay.
so that is how it's going to the overflow bucket. Because since I limited, otherwise it will go and occupy the next bucket if you are moving to hash prefix of 4. Okay. Oh yeah, that's it. Nothing much. So bitmap indices, all those has been covered.
Yeah. The bitmaps index. I wanted to ask, like, how did we create that for prefixes? We have seen that bitmap indexes previously. You said. So it has other department wise. So how did we create that?
For department wise,
The prefix
I-
what we are doing currently.
here we are done using the gender and income. If you wanted to create department wise, again, you just need to consider for each department, if you take one, another department is 0. That's it.
How the 32 it will come, sir? Because 32 department
No,
must be
no,
there.
that is hash prefix. This is bitmap. Bitmap just has 1 0 based on the number of records in your table. But hash prefix comes to exactly 32 or 64.
How it
That's
is created?
using the function. Sorry,
How it is created?
how it is created? I might need to look again once again. Or else they might have assumed by default here. I don't know whether it is given in lecture. I couldn't see.
It is called as what hash key, hash structure.
Yeah, that is hash key. Actually, the hash key value, which is come to a 32 bits.
It's
But
everything is
I'm
unique, right?
looking where.
Each every
Hmm,
department is unique.
yeah, but sometimes the hash value could be same if you have a larger database as here, millions of rows, billions of rows. I'm looking where that has been defined here. Bucket hash prefix they mentioned here. It goes up to 0 to 32,
Yeah.
but they
Is it
haven't
a,
given a function how they calculated hash prefix. Uh,
is it a random value or
Not a random value for each department. This hash prefix will be calculated using some hash function, which they haven't mentioned it. They just given a value directly.
okay, okay.
Okay, yes, then thank you. Bye bye.
Thank you, sir.
Thank you, sir.